Good morning, third grade, and happy Tuesday. So we have two more lessons on area and perimeter before we have our unit test on Thursday. So just to recap, we know that perimeter is us finding the outside of a shape by using addition. Perimeter is when we need to know the outside. Now, area is finding the inside of a rectangle. And we found that by finding side lengths and doing multiplication because our area of a rectangle or a square looks like an array that we learned when we were learning multiplication. So today we are going to find out how we can use area to compare rectangles with the same perimeter. So what we're going to figure out today is that some shapes have the same perimeter, but the areas are so different. So let's start. Here we go. Our friend Toby has 16 feet of boards to put around a rectangular sandbox. Since we're talking about around a rectangular sandbox, what does that mean? That means that we know that 16 is the outside or the perimeter, okay? So because we have 16 feet, that means that that's our perimeter. We can find different size sandboxes that we can have different areas. So for sandbox 1, we are going to use that 16 feet, use it for perimeter with one long rectangle, okay? We're going to have one line of unit cubes, right? So when we have one unit cube, we have 4 feet of perimeter. Why? Because we have 1 plus 1 plus 1 plus 1. When we bring it up to 2, that means we have a perimeter of 6. Why? Because it's 1 plus 1, it's just 2. Then 2 plus 2 is 4. And 2 plus 4 is 6. So if we keep going, we're going to eventually figure out how to get 16 feet. 3 and 1 make 8 feet. 3 plus 3 is 6. 1 plus 1 is 2. 3 plus 2 is 8. This means I have 10 feet of perimeter because 1 and 4 is 5. 1 and 4 is 5. That makes 10. If I have 5 feet on one side and 1 foot on the other side, that's 6 and 6, which equals 12. 6 and 1 means 1 plus 6 is 7, so 6 plus 1 is 7, which is 14. And finally, if I have a sandbox that is 1 foot wide and 7 feet long, then I'm going to get a perimeter of 16. Do you see how I'm just using addition, right? 1 and 7 is 8, 1 and 7 is 8, 8 plus 8 is 16. Now, what happens if I make a sandbox that are 2 units wide, right? What happens to my perimeter? I already start with a larger perimeter. Remember when we had 1 square here and it was only 4? Well, 2 and 1 make a perimeter of 6. Remember, 1, 2, 3, 4, 5, 6. I'm just counting the outside. Okay, so what happens when it's 2 by 2? 2, 4, 6, 8. 2 and 3, 2 and 5. 2 plus 3 is 5. 2 plus 3 is 5. That makes 10. Here we go. We got 12. We're looking for 16. We're at 14 now because 2 plus 5 makes 7. 5 plus 2 is 7. That equals 14. And finally, we can get 16 by having a 2 foot by 6 foot long rectangle. 2 plus 6 is 8. 2 plus 6 is 8. 8 plus 8, 16. Now, do you see the sizes of the sandboxes and how they're different? Well, sandbox 3, we're actually going to use 4. We're going to use 4 rows until we get to 16. So what happens when we have 4 rows of 1? We have 4 and 1, which is 5. 1 and 4, which is 5. That's how we get a perimeter of 10. We got to keep going. Here we go. We're going to add another row. What happens to the perimeter? It's 12 feet now because the only thing that changed was 8, 8, 2, and 2, which makes 12. Here we go. Another row gives us 14 because our lengths are 4 and 3. 3 and 4. 7 and 7 is 14. Now finally, when we have a sandbox that is 4 feet wide and 4 feet long. That's how we get 16, because 4 plus 4 plus 4 plus 4 is 16. Now, what's the area of this sandbox? See, this sandbox doesn't have a very big area, does it? Because it's 1 foot, 1 row of 7. Class, what's 7 times 1? 7. I could even count the squares to find my area, remember? Now, what if I have a 2 foot by 6 foot array, or what's my area? 6 times 2 is 12. So even though I have the same perimeter, do you see how the area is changing? Now we have a 4 by 4 foot sandbox. Guess what? 4 times 4 is 16. So if you're making a sandbox, which sandbox would you want? You would want the sandbox that has the biggest amount of square feet because we have the same perimeter. I don't want to play in a sandbox that looks like this. This one's okay, but this one's the best because you have more space on the inside. Isn't that cool? Same perimeter, different areas. Cool, huh? All right, let's keep going. So sometimes we're given a perimeter and an area. So we need to learn what the side lengths are by guess and check. Okay, so when I do guess and check and I'm making these rectangles that they're asking me to find, I like to use the area. Why? Because area to me is a multiplication problem. See, this is a lot of things that I have to add up to find perimeter. So I know that I can make 35 by multiplying what two numbers? 5 and 7. 5 times 7 is 35. So if I make a rectangle that is 5 rows of 7, I know that that's the correct area. So right now, I've got to check if that's the right perimeter. Do you know how? Adding. 5 plus 5 is 10. 7 plus 7 is 14. So 10 plus 14 is, hey, 24. That's the perimeter that we needed. So since the perimeter is 24, we already know that the area is 35 because we did 5 times 7 to get to 35. Now we know that the side lengths of rectangle A have to be how many units? 5 and 7. Right? So now that we're doing that, I better go plug in my Chromebook before it dies. So now that we've done rectangle A, now we're going to be doing rectangle B. Rectangle B has a perimeter of 24 units, but look at the area. The area is now 36, which means that we've got to make a different rectangle that has the same perimeter but different area. So let's start thinking about some ways that we can make 36. Remember how Mrs. Swallia did multiplication to find that answer? So some ways I can make 36 are 9 and 4. So 9 and 4, when multiplied together, equals 36. There we go. All right, so let's make a rectangle that's 9 by 4. 4 long, 9 wide. So if I add those things together, 4 plus 4 is 8. 9 plus 9 is 18. What happens when I add 18 and 8? The answer is 26. So is that the right rectangle? No, I did have the correct square units inside, but my perimeter is not correct. So I've got to try again. What else can I multiply together to get 36? How about 6 times 6? If I have 6 times 6, that also equals 36. So if I make it on my rectangle, let's see if that's the correct perimeter and if this is the correct rectangle. We already know that there's 36 squares in here because 6 times 6 is 36. That is the formula for area. But let's see, when I add 6 and 6 together, I get 12. When I add 6 and 6 together again, I get 12. What's 12 plus 12, class? Correct. The answer is 24. So my perimeter, yay, is 24 like it asks. I already know that 6 times 6 is 36. So guess what? My perimeter is the same, but my area is different just by a little bit. But my side lengths for this rectangle are 6 units and 6 units. So do you see how sometimes we're given the perimeter and the area, and we have to find the side lengths? So do you see how having the same perimeter means that we can also have different areas? I could have made this even more different with my perimeter. If I would have done 2 and 10, 2 plus 2 is 4, 10 plus 10 is 24, but is that anywhere close to 35 square units? No, that would have only been 20. So we have to figure out, sometimes we have to figure out what the best side lengths can be to get us the biggest area. All right, one more example and then we're good. So it says find a rectangle that has the same perimeter as rectangle C, but with a different area. So first, we have to find what the perimeter is. Okay, we can't find a rectangle with the same perimeter if we don't know what the perimeter is. So what is this side length? 1, 2, 3 over here, which means there's 3 over here. So what's 3 plus 3? 6. So then I have 1, 2, 3, 4, 5 down here, which means if 5 is here, I have 5 up here. So 5 plus 5 is 10. 3 plus 3 is 6. So 10 plus 6 is 16. My perimeter is 16. Okay, so remember, if I'm trying to get the same perimeter and I want to get an area that's larger, then I have to make a different size rectangle. So the area of this rectangle is what? Let's see, 3 times 5 is what, class? Oh, not 16, it's 15. 3, 6, 9, 12, 15, or 5, 10, 15. Okay, so let's figure out how I can make a rectangle that is 16 units on the perimeter, but with a different area. So I guess this doesn't ask for a larger area, it just asks for different. So if I put a row right here, and this is my rectangle, is that enough to get to 16 units on the same perimeter? No, it's not. This perimeter right now is 2, 3, 4, 5, 6. So that is not the correct. So I'm going to keep going though. Here we go. Is that 16? 2, 4, 6, 8. Nope. How about this? Is this 16? 2, 3 is 5, 7, 10. Not yet. All right, here we go. How about another row? 2 and 4 is 6. 2 and 4 is 6. That's 12. How about this one? 2 and 5 is 7. So this 2 and this 5 is 7, which makes 14. So if I add one more row of 2 squares, I'm going to have a perimeter of 16. I can check this by adding the sides. 2 plus 2 is 4. 6 plus 6 is 12. 12 plus 4 is 16. So I'm correct. Is this a different area? The rectangle D has 16 units as the perimeter. So what is my area? I can do this one of 2 ways. I can count them individually, or I can stretch my thinking and I can do the formula for area, which is length times width. 2 times 6 is 12. Are my perimeters the same? Yes. Are my areas different? Yes. So now let's answer this question. The area of rectangle C is something than the area of rectangle D. So is rectangle C greater or less? Let's see. Is 15 greater or less than 12? If you're thinking greater, you're correct. Great job. So explore this new way of thinking. Remember, perimeters can be the same, but the shape of the rectangles changes the area. The side lengths change the area, okay? So just because you have the same perimeter does not mean you're going to have the same area. So I want you to explore that while you're doing your personal math trainer, okay? All right, guys, I hope you have a great Tuesday. I will talk to you tomorrow.